We're going to look at intro to algebraic proofs in this lesson. Fun stuff, algebraic proofs. So first thing I want to do is define a proof. A proof is just an argument that uses logic to show that its conclusion is true. And there's different ways that we can use logic when we're talking about algebraic proofs. So you've actually used all this when you've used math. What we're going to do is just kind of give a name to it. So say we had x minus 10 equals 2. Well, how do we solve from there? Well, we know that if we have a negative 10, we have to add 10 to both sides. Just like so. And when we do that, this is actually called the addition property of equality. It's called the addition property of equality because we're adding 10 to both sides, so it's equal. Equal to both sides, so that's called the addition property of equality. What the next step would actually technically be is simplifying. So say this was step 1, step 2 would be simplify. And so then you would get x, those would cancel, equals 12, and that would be your answer. So that's addition property of equality. What if we had x plus 10 equals 2? Well, here we would have to subtract 10 to both sides. That is known as the subtraction property of equality. Right? Same thing as addition, and then from there you simplify. Subtract, so negative 8 would equal x. So we have addition property of equality, subtraction property of equality. We have, let's say we have 3x equals 18. Well, you could probably figure out when we divide by 3 to each side, that is the division property of equality. And then you would simplify to find x equals 6, or if we had 3 over, let's call it this. If we had x over 3 equals 2, well, that would be, when we multiply the 3, multiplication property of equality. So those are some easy ones, and I'll show you how we use those in a minute. A couple other ones, we've used these words in past lessons for logic, but now we're talking about them algebraically, meaning numbers. So we have 2 equals x. Well, if we want to flip the x from this side, from the right side to the left, switch it over here and switch the 2 over here, well, that would be x equals 2. Still the same thing. That is known as the symmetric property of equality. Just switching them. That's all it is. Reflexive property of equality is where they stay the same, and it's just a mirror, so you won't often use that one as much, but that is the reflexive property of equality. You have the transitive property of equality, meaning if A equals B, B equals C, therefore we can conclude that A equals C. That's transitive property. Discussed that before, and there will be examples in which we use that to show it algebraically. And then you have the last one here, substitution property of equality. So we have a problem of x plus y equals 8. But we are given that y equals 4. Well, what we can do, if we know what y is equal to, then we can take what it's equal to and substitute it in for y. So then it would become x plus 4 equals 8, and you could solve. In the last lesson we had a circle maybe with a radius of 2. And we know that our formula equals pi radius squared, and we know 2 equals our radius. So therefore we were substituting, well, I guess it'd be 2, in for r. And so that's just the substitution property of equality, where you know the value of a letter or whatever of a variable, and then you substitute the value in. So let's look at an example of how we would use these. say we are given example 1, and it says solve this problem, but provide a justification for each step. Provide justification for each step. Well, this is an easy problem to solve. Okay, I know that y'all can solve this, but here's how we go through the steps. Okay, we start with what we are given. So this, we just move down here, and this is what I call my statement column. And this is our reasons. This is the reason we could make a statement. Well, this statement is just a reason being given. That's just what's given to us. From here, what would be our next step to solve? Well, it would be doing 2 times x and 2 times 1, right? Now, we didn't talk about this property, but when we do that, we get 2x plus 2 equals x plus 9. And what we do is just we would write in the distributive property. Now, notice this does not say of equality. Why does it not say of equality? Because we only distributed on this side. We didn't distribute on this side, so therefore we just call it the distributive property, and it is left on its own. The next step, once we have 2x plus 2 equals x plus 9, the next step would be to get rid of the 2, trying to get x by itself. So we subtract 2 on both sides. Like we said, that's subtraction property of equality. This is what is technically left at. So when I actually solve for 2 minus 2 to be 0, when I actually do 9 minus 2 equals 7, that is me simplifying. So now we have our simplified version of our subtraction property of equality. Our next step here, we want to subtract the x. So this is my simplified. I lost my train of thought. So we subtract x here to both sides. So it's subtraction property of equality. Once it crosses out, that becomes 1x equals 7, and that's just simplified. But there's an example of how you would do an algebraic proof. It's nothing too fancy or difficult. You're just kind of adding a explanation for each step. But that is the end of lesson 24. You'll have different examples you can look at, but that should give you a general idea.